All right, in chapter 1, we are going to talk about functions and their graphs. And so starting out in 1-1, we will look at lines in the plane. And the plane is really just your x and y axes. So what we're going to look at is finding slopes, writing linear equations given points on lines and their slopes, using slope-intercept form, and then using slope to identify parallel and perpendicular lines. So just a few reminders about slope. Remember that in order to find the slope of a line given 2 points, we're going to use that equation m equals y2 minus y1 over x2 minus x1, and we use that letter m as slope, or you can think about it as the change in y over change in x, or you could also think about it as the rise over the run. Remember, with the slope of a line, if the slope is positive, it increases from left to right. If the slope is negative, it decreases from left to right. A zero slope is horizontal, and a line with an undefined slope is vertical. So when we're talking about equations of a line, and we'll get to this in a little bit, but with those horizontal lines, those are y equals some sort of constant equation. So maybe a y equals 2 or y equals 7. For a vertical line, those are x equals a number or a constant type equation. So point slope form, this isn't a form that we've used a whole lot, but this is a form that we're going to start using a little bit more, especially as we get into calculus. This is the form that you tend to go with, so it's kind of worth knowing. When you use your point slope form is when you're given a point and a slope, or when you can identify a point and a slope. So your point slope form is y minus y1 equals m, which is your slope, times x minus x1. And the y1 and the x1 are from the x and the y from the point that you're given. Looking at sketching graphs of a line, remember that if you're given a graph, you could potentially find its equation, or if you're given an equation, you could sketch the graph. And probably the easiest way to sketch a graph is from slope-intercept form. So that's the form, the y equals mx plus b, right, where m is your slope and your y-intercept is your b. That's the form that you're probably most used to using, where if you were graphing it, you would first graph that y-intercept, that b value, and then for your slope, you would do your rise and your run, graph the next point, and then sketch that line between the 2 points. So looking at this first example, finding the slope of a line, just going through that, remember that the slope of a line, that formula is y2 minus y1 over x2 minus x1. So if we use the first point as our x1 and our y1, and the second point as our x2 and our y2, if we're calculating the slope, we would say y2 minus y1 over x2 minus x1, which would give us 1/5. So we would rise 1 and we would run 5. Point slope form, remember your point slope form was the y minus y1 equals m times x minus x1. Right? Your point is like your x1 and your y1. If you're given the slope, that's your m. So writing an equation of a line that passes through the point with a slope of 3, we would say y minus y1. So minus a negative 2 would be plus 2 equals our slope, which is 3, times x minus x1. And unless they tell you that you need to put it in some other form, you really can just leave it in point slope form. So for example 4, if we're determining the slope and the y-intercept of each linear equation, so usually if you're identifying or determining a slope and a y-intercept, you probably want to put your equation in slope-intercept form, which is that y equals mx plus b form. So for part A, if we were to put it into y equals mx plus b, we would subtract x, and then we'd have plus 2. So looking at this then, we know that our slope is negative 1, and our y-intercept would be 2. Now, when you look at part B, we just have a y equals equation, right? And if you have a y equals equation and there's no x, it really means you have no x and you're plus 2. And remember a y equals equation, if you were to graph it, if y equaled 2, it would mean all of the points would have y equals 2. So you have this horizontal line. So your slope in this case would be 0, and your y-intercept would be 2. So just some general equations of lines. Your general form is your ax plus by plus c, where this b, if you notice, is a capital B. That does not represent your slope. So if you're in general form, all of your x's and y's, so x and y are on the same side, right? You move that constant over as well, and your a needs to be a positive whole number. So no fractions, no negatives for a. So you might need to clear a fraction or multiply everything by a negative in order to get a to be that positive whole number. The reminder about the vertical line is an x equals, horizontal is y equals, slope-intercept form, and point-slope form. So if you need that reminder about what any of those equations are, this would be a good slide to come back to. And then just parallel and perpendicular. Remember, parallel lines have the same slope, and perpendicular lines have opposite reciprocal slopes. So for this one, if one of your lines had a slope of 1/2, a perpendicular line would have a slope of -2. It would be the reciprocal and it would be opposite. So for this next example, it says find the slope-intercept form, so that's your y equals mx plus b, of the equation of a line that passes through the point. So they're giving us a point and it's parallel to this line. So if it's parallel, that means it has to have the same slope. So what we first need to do is figure out what is the slope of that line. So let's put it into slope-intercept form. If we divide by 3, we get 2/3 x minus 5/3. So the fact that it's parallel means if this slope is 2/3, the line we're dealing with is also going to have a slope of 2/3. Okay, so two ways now that you can approach this. You're given a point and a slope, so you could use your point slope form and say y minus y1 equals m times x minus x1. And then we could simplify. So we could say y plus 1, distribute our 2/3, so 2/3 x minus 4/3. And then when we subtract 1, we get 2/3 x. And if we're subtracting 1, that's like we're subtracting 3/3, so we get minus 7/3. So that would be your slope-intercept form. Another way that you might want to approach it that maybe makes more sense to you is to use this form to start. So if we use y equals, let me switch to black, it's going to show up better. Y equals 2/3 x plus b. You can solve for b using this point, where 2 is your x and -1 is your y. So you could plug those in and solve for b. So you'd have -1 equals 4/3 plus b. And then when you subtract 4/3, you get that your b is -7/3, right? Which then gives you, again, that same equation. So either way that you want to get there is fine. And then this next example, equations of perpendicular lines, we need to find a slope. Again, we're given that point, but this time it's perpendicular. So remember, we need to figure out what the slope of that line is. So if our slope is 2/3, then a perpendicular slope would be -3/2. And for me, I always use point slope form, but again, like that previous example, you can use either way. But I'm just going to go y plus 1 equals -3/2 times x minus 2. So y plus 1 equals distribute the negative 3/2 plus 3 when we distribute it. And then when you subtract 1, we get y equals negative, I dropped my x, negative 3/2 x plus 2 for our equation. And that is it for 1-1.